So welcome to my YouTube channel. My name is Vincent Nando. I'm a lecturer at University of Nairobi and based University. So in this course, we are going to study about linear algebra from the start up to the end. And I hope the course will be useful to you. So let me project the course content. So the name of the course is called the linear algebra. As I've told you, my name is Vincent Nandwa Terry. I teach at University of Nairobi. Currently, I'm pursuing my PhD in applied mathematics. So I also teach at Daystar University. And the course linear algebra has different names. Like in the School of Economics, it's called XEQ 209 linear algebra. This School of Economics, University of Nairobi. And at Chiromo campus in the School of Mathematics, the course is called SMA 203 and it's called Linear Algebra 1. At Kikuyu campus, University of Nairobi, the course is called TMA 203 Linear Algebra 1. Kenya Science at University of Nairobi, the course is called SMA 203 Linear Algebra 1. And at Daystar University, the course is called Math 312 Linear Algebra. So this unit may be the first in your course to study linear algebra. So it bridges the gap between the main computation and abstract mathematics. So we'll start from the computations, and then as we proceed by, we'll be able to prove some things which are not computational but abstract in nature. And so the biggest question will be to ask ourselves, what is linear algebra? So linear algebra is a branch of mathematics aimed at solving systems of linear equations with a finite number of unknowns. So the core objective of the course is to solve systems of linear equations. So there are two main questions that one always would like to get answers. So one is the characterization of the solutions of the system of linear equations. So the question will be, are there solutions to a given system of linear equations? And if there are solutions, how many solutions are there? And then the next question that one would like to get an answer to is, how do we find the solutions to a given system of linear equations? And then, so the question will be, how does the solution set look? And what are the solutions to that given system of linear equations? Those are the two main questions that we'll be always asking ourselves whenever you're solving problems in this course. And so the main course purpose is to equip students with some basic concepts of linear algebra that may be required in economics, mathematics, and other courses. So the course linear algebra is very applicable in many fields, ranging from computer science, chemistry, physics, biology, economics, advanced mathematics, even in programming. All those fields involve some concepts of linear algebra. So the course is very, very key. And so this being an introductory course is to equip the students with some basic skills that can help them understand computational and most abstract things related to algebra. So the expected learning outcomes for this course include solving linear systems of equations by row reduction and using matrices. And then another expectation is to perform matrix operations like multiplication, addition, subtraction, finding the inverse of a matrix, and also finding determinants of matrices. And then another learning outcome for this course is to characterize invertible matrices, and then finding inverse of matrices. And then another outcome is to determine the span of a vector space and the independence of a set of vector spaces and subspaces. And then also another learning outcome is to identify and apply properties of determinants, and also use Cramer's rule to solve some systems of linear equations. And then we're also interested to study about finding the eigenvalues and eigenvectors of matrix, and then compute inner products of a set of vectors, and then finding orthogonal projection of vector onto a vector space. So in summary, the main chapters to be covered. So we'll start with systems of linear equations. So under systems of linear equations, we'll introduce what we call systems of linear equations. So define what a system of linear equations and give some examples. And then carry out row reduction and transforming systems of linear equations or matrices into echelon form. And then solving systems of linear equations by Gaussian elimination and Gauss-Jordan elimination methods. And then apply systems of linear equations to solve some real world problems in electrical engineering, economics, and mathematics. And then apply also the concept of solving systems of linear equations in economics problems. And then another chapter is matrix algebra. So in matrix algebra, we'll be interested in doing some operations on matrices, addition, subtraction, and multiplication, and then state some properties of matrix, and then matrix operations, and then find inverse of a matrix, and also define what we call elementary matrices, and then also apply matrix operations to solving systems of linear equations, and then also see how concept of matrix algebra can be applied in economics and other fields. And then another chapter is determinants of matrices. So we introduce what we mean by determinants, then determine determinants using elementary operations, and then set some properties of determinants, and then state and see how we can apply Cramer's rule, and also see how the concept of determinants can be applied to economics problems and other problems in different fields. And then another chapter is what we call eigenvalues and eigenvectors. So in eigenvalues and eigenvectors, we start by defining what we mean by eigenvalue and an eigenvector, and then characteristic equation, and then symmetric matrices and orthogonal diagonalization, and then see how we can apply eigenvalues and eigenvectors to solving linear algebra problems. And then the second last chapter is vectors in 2-dimensional space and 3-dimensional space. So we introduce what we call vectors, and then give some examples, define and give examples and evaluate problems on norm of a vector, and carry out some vector arithmetic, and then also define and do some problems on dot and cross product of vectors. And then finally, we finish with the vector spaces, so general vector spaces. So define what we mean by vector space, and then vector subspaces, and then do problems on linear independence and spanning sets, define and do examples on basis and dimension, and then define and do problems on row spaces, column spaces, and null spaces, and then define and evaluate problems on rank and nullity of a matrix. So that's majorly the main thing that should be covered in linear algebra course, and we'll study all of them up to the end from the beginning. So thank you, and I wish that the course will be useful to you. Ensure that you follow through the lectures, and in case there's something that's not clear, feel free to send me an email. My email is on this first page, vc number@unbi.ac.ke, or you can as well WhatsApp me on 0705 050 158. And also, please, I kindly request you also to subscribe to my YouTube channel so that you can always be getting updates on the lecture series that will be posted there, not just for linear algebra, but also other courses like numerical methods and engineering mathematics and applied mathematics courses. So with those many remarks, that was just the introduction of the course. And so in the next lecture, we'll now start discussing about systems of linear equations and doing some problems on that. So thank you and have a good day.